So we know two important formulas. One is AX, oh, sorry, x squared plus bx. We can directly factor ax plus b. Another one is ax squared minus b squared. And we can directly factor x minus b, x plus b. Okay. Yeah. So, example. Try this problem. Try this problem. Okay. Okay, I'm gonna write down the answer on board. So if you plug in the x equals 5, that is 0, then 5 squared gonna be 25, right? So 0 over 0. So for this guy, we can write down as x minus 5, x plus 5. Right? We can use the factoring method. Factor this guy, x squared minus 25, and then cancel out. And then we're gonna get x approaches 5, x plus 5. That equals 10. Right? Equals 10. Now let me give you guys another one. Oh, sorry, that is right. You done? Great. What's the answer? 1/2. That's right. Okay, so let me do it on board. X approaches 6, x factorial method, x minus 6, x plus 6. Right? And then cancel out. And we're gonna get x approaches 6. Understood? We cancel out, and we have 6 over 6 plus 6, 1/2. Okay, so the limit of this guy gonna be 1/2. 1/2. Okay, now let's continue. This time I'm gonna give you a tricky one. Okay. So limit x approaches -3. Okay, calculate this one for me. Here x approaches -3. Okay. And of course, I need to be really specific. What's the answer? What's the answer? Fantastic. Good job. So let's check the this guy. When we plug in -3 here is a 9, right? So when we plug in -3, gonna be -3 squared minus 3 times -3. We're gonna get 18, right? 18. And the denominator gonna be a 0. -3 squared is 9. So 18 divided by 0 is not a 0 over 0, right? So this guy is infinity. Someone divided by 0 equals infinity for the limit, okay? Or you can say this is undefined. So far, we didn't learn anything about infinity. You can say that is undefined. But later, we're going to address the infinity. Actually, there can be a positive infinity, and there can be a negative infinity, okay?
On Math Lab, is it going to be picky as in which one we put?
Put an infinity, I think. Infinity may be the good choice.
So if we would put it as undefined, it would probably mark it wrong.
Yeah, I think so. I think so. It depends on the my math lab. Try another one. It should be the same, undefined or infinity, right? Because when you plug in the 2 in the denominator, you're gonna get 0, 2 over 0, infinity. Okay, or undefined. Okay, now we can move on. We're gonna go to another level. Today we're gonna learn one-sided limits. One-sided limits, okay? So let's one-sided limits. Fx equals k. Okay, and we call k the limit form. Limit from the left or the left hand limit of fx whenever x is close to, but to the left of C on the real number line. And that's first definition. We call this guy left-handed limit. We use C minus. Okay, C minus left-handed limit of x of fx. And another one we call and call L the limit from the right or the right hand limit of fx whenever x is close to, but to the right of C on the real number line. Okay, and we call this guy is right hand limit. Right hand limit, and we use C plus. Okay, C minus for the left hand limit. C plus, that means right hand limit. Right hand limit. And let's take a look the pictures. And the picture can help you guys to understand what is left hand limit, what is right hand limit. The first picture. Fx, we have L here, we have C here. Okay. So for the left hand limit, gonna be what? Gonna be we're gonna approach C from left. Okay, approach C from the left. Okay, and then the curve from the left approaches L. Okay, it's not like the limit we defined before from both sides. Here, just a one-sided limit, right? That's the only difference, one-sided limit. Now, the same thing. That is L. Okay. And right hand limit gonna be what? Approach C from the right hand side. Okay. And then the curve approaches L from right hand side. Right? So it's L. So that's the definition. Okay, that's the definition. So the difference between the limit and the one side limit is always about both sides or one side. Okay, both sides or one side. Now let's take a look one example. The first example is here. Oh no, I will not address the example. I will address the theorem. Theorem 1. If x approaches C, if x equals L, if only if the left hand limit equals the right hand limit equals L. Why is that? Why is that? I draw the picture. So from the definition of the limit, we know approach the C from both sides, right? Approach C from both sides, and the curve approaches L, right? From both sides. And now let's take a look at this guy. For the left-hand side limit, that means we only consider this part. Okay, I just cover this part. We only consider the left side. So when x approaches C here, and the curve approaches L. So that's the left hand limit, right?
So whenever the C has a negative, it's left hand, and whenever C has a positive, it's
No. That's not a negative. This is a notation. C minus means from the left. Or you can treat this guy as left.
and so the
C plus means right. Okay, it's nothing to do with minus, nothing to do with subtraction or addition. Okay, or negative or positive. It's always about direction. So C minus means from left. C plus is right. Okay, right direction. So for this guy, we only consider right-hand side. So when x approaches C from right-hand side, the curve approaches L. So if both of them equals L, that means the definition of limit, right? Approach C from both sides. That means the definition of limit. So these two are equivalent, okay? If we see the left-hand limit and the right-hand limit equals each other, equals L, that means the limit equals L. That's it, okay? Now let's take a look at an example. Okay, that's a very interesting curve. So here we have a circle. We have a circle here. Circle, circle. Okay, that's a solid point. Now I have a bunch of questions. What is the limit? X approaches 1 minus. 1 minus, that means the left hand limit. B 1 plus. C E F H I Okay, so let's take a look at the first one. So for the first one, it's very clearly, we're gonna calculate the left hand limit, right? Left hand limit. So when X approaches 1 from the left, left gonna be this direction. X approaches 1 and the Fx approaches from the left. 3, right? 3 from the left. And let's take a look. The limit, the right hand limit, X approaches 1 from the right hand side, and the curve approaches 3, right? 3. Clear? And the limit, Fx, that means approaches from both sides. So approaches both sides should be 3. Right? Now, what is F1?
Wait.
Undefined. Draw the vertical line. That's an empty here, right? It's a circle, so undefined. The same things for X approaches 2 from left hand side, approaches 2 from left hand side, and the curve approaches what? 2. Very good, good job. And now for the right hand limit, X approaches 2 from right hand side, and the curve approaches what? 5. Aha. Did you see it? So what is the limit of this guy? Doesn't exist, right? Here requires what? Approaches 2 from both sides. So when you approach 2 from both sides, it gives you different numbers. That means doesn't exist. Right? Doesn't exist. Or you can see the left hand limit doesn't equal to the right hand limit. These two doesn't equal each other. These two doesn't equal each other. That means this guy doesn't exist based on this theorem. Okay, based on this theorem. So we can see if doesn't equals this guy, that means okay, that's the very important criteria to decide whether this guy exists or not. Okay, so the left hand and right or left hand limit equals right hand limit. That means this guy exists. Otherwise, doesn't exist. Okay, it's very simple. And for this case, since we find the left hand limit doesn't equal to right hand limit, so this guy doesn't exist. Now, how about this guy? Equals what? 2. Very good. Draw the vertical line. We find a solid point here. So that is 2. 2. Okay. Now, I'm going to give you guys an example. Let you guys try it. Okay. Now, here we have 2 circles, here and here. Okay, 2 circles. Now the first example is limit x approaches 1 hx b limit c limit x approaches 1 hx d h1 e x approaches 3 f x approaches 3 plus f h3 h limit x approaches phi, hx I limit x, sorry. Okay, now let's do it together. So x approaches 1 from the left-hand side, right? So we have the curve approaches this point, right? From the left-hand side, approach this point is 1. Okay, now that is a right-hand limit. So approaches 1 from right-hand side. And this curve approach here. That's gonna be 2, right? 2. Now, how about this guy? Doesn't exist. Very good. It's because these two doesn't equal each other. Or you can see from the curve. So approach from both sides, we're gonna give you different numbers, right? Different numbers. What is H1? Undefined. You draw the vertical line, you couldn't find any solid point. So undefined. Or doesn't exist. And for this guy, approach 3 from the left-hand side, we're gonna get 3. And approach 3 from right-hand side, we still got a 3. And how about the H3? 3, very good. We draw the vertical line, there's a solid point here. And how about this guy? Approach 5 from the left-hand side. That equals 3, very good. How about this guy? From right-hand side. Very good, very good. Yes, we're missing the curve, right? The curve is missing. Okay, very good. Now let's take a look. Another weird question. Take a look. This guy. And that is gx. There's a circle here. And I define. Oh, I want you guys to try this one first. X approaches 2, 3, 4, G2. And so another one. And I'm gonna address a little bit for the positive infinity or negative infinity. What does that mean? Positive infinity, when x approaches positive infinity, x goes this direction. Okay, so this direction is the number is increasing, right? Let's go to the positive infinity. And when x approaches negative infinity, that means the x goes left. Okay, goes left. Okay, now try all these questions. Here I put a arrow. That means the curve always goes up. Right? I put an arrow here. That means the curve is not stopped. It always goes down. Okay. Good. Okay, let's start it together. So here for the left-hand side limit, from here, right? And the curve gonna approach 2. And x approach 2 from the right-hand side. The curve approaches 2, right? And the limit of this guy approaches 4 on both sides, so you're gonna get 2, right? 2. And what is G2? 1, very good. Now how about this guy? X approaches infinity. That's a big challenge. X approaches infinity.
So we are all in.
The curve always goes up. That means approaches positive infinity. Understood? Now, for this guy, x approaches negative infinity. The curve always goes down. That means negative infinity. That's it. Okay? Very good. Very good. Now the last example. And we have -2 here. We have another one. So -2. -3. And 1. Okay. Now limit x approaches -3. B x approaches 3. X approaches -3. B. X approaches -3. Or x equals -3. E. F. X approaches -2. H. X approaches -2. I. F -2. Try it.
On every date, they both X approach -2. Am I just making, am I not seeing the negative?
-2,
Negative.
negative. This negative is the negative value. Okay, this negative at the top is direction from the left. Okay.
-2 without positive.
And is this one gonna be your last example? Will you guys watch football during the weekend? Will you guys watch football? You are not a big fan of LSU at all. Okay, never mind. What? You done? Great, great. I think most of you guys should get it done. It's not too hard, I think. Okay. Also, the curve is a little bit weird, but I think if you follow the rule, you should get it. Now, for the first one, x approaches -3 from the left hand. Oh, sorry, that's the right hand side. From the right hand side, right? -3 plus from right hand side, and we find the curve approaches what? -2. Very good. Very good. And approach -3 from left hand side, -2. So this guy equals -2 from both sides equals -2. How about f -3? Fantastic. You get it. Okay. You know, I teach I teach you this class, Math 1431, already 3 times. For the previous two classes, nobody can get the right answer for this one. But now in this class, some students, at least some of you already get the answer 1. That means you guys is way above the average. Okay, you are very intellectual. Some students might even have some gifted in the math, right? Maybe you can choose your math as your major. Okay, let's continue. X approaches -2 from right-hand side, right? And we found the curve is here, not the downside, right? There should be a 3. Okay, the curve is here on the top. And X approaches -2 from the left-hand side. The curve is down here, -3. Clear? Do you know the difference? Understood? So X approaches -2 from left-hand side. The curve approaches -3, right? Left-hand side. How about this guy? Doesn't exist because these two don't equal each other, right? Very simple. How about F -2? 3. Draw a vertical line. There is a solid point there, right? 3. That's it.